Hello and welcome to another video on advanced topics of Azure Machine Learning. Today I'll show you one more example of using Azure Machine Learning to solve an interesting task, which would be answering COVID questions based on the dataset of COVID papers using DeepPavlov natural language processing library. First of all, let me mention what is open domain question answering, which is the technique that we will be using in this example. So normal question answering is when you have the relatively small piece of text and a question, and the neural network picks up the answer to that question. However, in the real world, we have the slightly more difficult problem. We have large amounts of text, like for example, the whole Wikipedia, and we want to find the answer in this Wikipedia. So we want to be able to take this large amounts of text and ask any question about it. For example, if we take Wikipedia, we can ask when did Guinea pigs originate, and it will give us the answer. Or when did the Lynmouth floods happen, and it will tell us 1804, exact specific answer to our question. So in my case, I would use the dataset of COVID papers as this original source of information. So I want to take this dataset, which is called Cord19, which is available on Kaggle or on LNAI website, and it contains it contains now over 400,000 papers on COVID. And they are very different, like on different topics, but we want to be able to query this in the natural language. So for example, I want to be able to ask what is a coronavirus, and it will tell us it's a respiratory tract infection. Or what is the reproductive number? It will tell us 5.2. So those are actual results that I achieved during the training. So you can already see that the model is giving some kind of meaningful results, and I will show you how to train this kind of model. So this model would be based on the pre-trained language model called BERT. So BERT is a language model. So language model is a neural network which models the language. So it understands pretty much how language works, how it's structured. And BERT can do two tasks. It is called masked language model because it can predict masked out words. And it's also has the next sentence prediction capability. So, for example, if I have this sentence, during holidays I like to, and then the missing word, do something with my dog. The model will predict the word which should be there. Like it would say with a probability of 0.85, it should be play with my dog. With 0.05, it should be sleep with my dog or fight with my dog. So this is masked language model. And then next sentence prediction means that I can predict the probability of the next sentence. So I would say if I want the next sentence to be "it is so cute," it would be 0.8, the probability that that is the correct sentence. So the good thing about the BERT model is that it was trained on the wide variety of texts. So you don't need any data set, like any specific label data set to train it. You just take huge amounts of text and you get pretty good understanding about how a language works. However, this is the really huge model. It contains 345 million parameters. So it's almost impossible to train this yourself. I mean, you would require a lot of computing power. So instead, we use BERT as a pre-trained model to solve some specific tasks. So for example, if I want to do text classification, if I want to, for example, classify spam, or if I want to classify phrases as insulting or not insulting, I would take input text, I will process it through BERT to produce some features. And then I would train the classifier on top of those features to produce the probability vector. And it would tell me, okay, this is the probability that this text is insulting. If I want to do entity extraction, I would also pass the input text through BERT. And then I would train, instead of classifier, I would train mask generator. So it would pretty much highlight the word and tell me this is the location. If I want to use BERT for question answering, I would give it input text and the question. There would be also the question as part of the input text. It would give me features, and then I would have bounds generator. So it would generate me that here are the positions in which my answer is contained. So it will give me the numbers of words with my answers. So to do that, I would use the library called DeepPavlov. DeepPavlov is one of the well-known libraries for natural language tasks. And you can install it using pip. So you can pip install DeepPavlov. And then the way it works is that it has some kind of text processing pipeline, which you can define. And you can train this pipeline as the big end-to-end model. So as you've seen on the previous example, all those were examples of pipelines. I combine some models. So in this case, I combine BERT and classifier. I can combine BERT and mask generator to form the pipeline which I can train end-to-end on my example. So that is the way the DeepPavlov works. It also contains already pre-trained models. So for example, if I'm using BERT in my model, I can specify my pipeline using JSON config file. And I can say I want to use BERT as one of the processing steps. And then I would be able to say DeepPavlov install config JSON. It would install all required libraries. So for example, some models require TensorFlow, some models require PyTorch. Then I can say DeepPavlov download config JSON, and it would fetch all required pre-trained model weights. And then you can say DeepPavlov train config JSON, and that would train my end-to-end pipeline. And of course, in the pipeline, I also need to specify the path to my dataset and the format of the dataset and all the details of when to get the data and where to get the data. So here is the way config file is defined. So suppose I'm using the simplest problem, intent classification. So I have some input phrases and I want to match those phrases with some intents. So how would the config file look like? It would be a JSON file. First section would be specifying where to take the data from. So I would say dataset reader, and I want basic classification reader. And it would come in this reader. I would have two fields like X, which would be text, and Y, which would be intent. So I define fields in that input file, and I also put the data path. And then dataset iterator specifies how to iterate through this dataset. So in this case, I want to split it into train and validation set. And then the main part of config would be chainer. Chainer specifies how to build the pipeline from simple parts. So the chainer would specify the input variable, which would be X. It would specify output variable, which would be Y, output intent. And it would specify the output parameter for prediction. Like in Y is the actual intent which I want to train my model on, and out is the predicted value of my model. And then in the chainer there is pipe. Pipe is the list of intermediate steps of the pipeline. So how this and I also define the parameters, like what would be the batch size, what would be the metric, and so on. So how the pipeline looks like in chainer. So in my case, if I want to do intent classification, what I need to do, I need to take my input vectors and I need to vectorize them using TF-IDF vectorizer. So I would end up with the vectorized version of the pipeline xvec. And then, of course, because intents, they are just some kind of words, I need to produce the classes vocabulary for them. So I would say I would take another step, which is called classes vocab, and I would produce YIDs. And those YIDs and xvec, they would be input to logistic regression classifier, which is like the simplest possible classifier. And in the output, it will give me as output YPred. So that would be the pipeline. And the way it would be defined for each pipeline step. So for example, for classes vocab, I would say here is my classes vocab. The input would be Y, output would be YIDs, and I need to fit on Y. I need to fit this model on Y. The same is true for all components. So in this case, TF-IDF vectorizer I will take from scikit-learn, and logistic regression I would also take from scikit-learn. So that would be a very simple intent classifier. So, but this describes the general idea of how pipelines are built. So for open domain question answering, I would have the following pipeline. It would take two steps to answer the question on the large volume of text. So first of all, I would start with a large document collection, which would be like either Wikipedia or a data set of all COVID papers, and I would use Ranker to find the best matching documents in this collection. So by document, I mean rather short paragraph of text. So it's not like the whole big, huge document. It is the piece of text where the answer is contained. So the job of a ranker is to return me the IDs of documents from this collection where I can find the answer. So it takes question as an input and produces the references to text. And then there would be another component called reader, which is trained on the dataset called Squad. Squad is the dataset of simple questions and answers, and it learns to pick up the relevant portion of the sentence for an answer. So if I say who destroyed the Death Star, it would give me the range of documents, and then Squad would find the best answer in this collection of documents and tell me Luke Skywalker. So this process, in fact, has been described in the DeepPavlov blog, and my job is to adapt it to COVID dataset. So what we'll use from Azure Machine Learning in this case is Jupyter Notebooks, because to train this model on the cluster is not very efficient, because DeepPavlov libraries, they are very heavy, like pre-trained BERT model and Wikipedia corpus, which is required for this task. They occupy several gigabytes. So it is more convenient for us to manually set up this environment first on the Jupyter compute and then use it. So we can use non-GPU compute first to prepare the data, to extract the text from the dataset of COVID papers, and then we can switch to GPU compute to actually train the model. So the link to the dataset, you can find it online on the internet, and then let's see how to extract the data. So I will go to datasets, and I first define the dataset as the link to a web resource. So I provide the link to this dataset, I call it chord, and I select dataset type as file because it is indeed a tar.gzip file. So this gives me the definition of my dataset. I can go in, and in consume section, I can see I have the Python code which can be used to get this dataset. So I can grab this code, go to notebooks, and paste it here. And with one click, I get access to this online dataset. Then, because it's a file dataset, I can mount it into a directory. And you can see once I mount it, I can see this file. And the only thing that I need to do, I need to extract it. So I use tar command here to extract all the papers from this dataset. And you can see there are a bunch of JSON files. So from JSON files, I can write a short Python program, which will extract abstracts and body text of the paper and put it into a text file. So as a result, I would get text files in the directory called text, and those files are extracted text from the paper. And here is how this extracted text looks like. I will just show one of them. So this is the text, and I have the all contents of all papers extracted as in one directory. So now what I need to do, I need to train the DeepPavlov model. So again, I can use the Jupyter Notebook for it, and I will show it. I'll show the code to you on the slides because it's a little bit easier to see. First of all, what we need to do, we need to install DeepPavlov. So in the notebook, we say pip install DeepPavlov. And then we start with the existing example, which is provided as part of DeepPavlov installation, which is called N or DQA Infer Wiki. So this is the English open domain question answering trained on Wikipedia. So we install all the libraries, we download it, and after that we can start querying the Wikipedia immediately. We don't need to train it because it's already pre-trained. So to ask questions to the model, we import the build model, and we build this model providing the config file. So config file is built into DeepPavlov. So we can say configs.odqa.english DQA infer wiki. So you don't need to like even get this file somewhere on disk. It is built into the distribution. And then once I build the model, I have this variable called odqa. I can say odqa and give the questions like where did guinea pigs originate, and it will give me the answer as the result. And when did Linmo's floods happen? 1804. So our model is working. Now what we need to do to make it answer COVID questions, we need to do two things. First of all, we need to train the ranker on our text dataset. So instead of the Wikipedia ranker, so that the ranker picks up files from our dataset. And then we need to replace the question answering model with more recent model based on BERT networks, instead of the built-in model, which is based on RNet, which is not as expressive. So let's do those two steps. So right now, when we have set up the model, it is based on this English ODQA in FairWiki, which includes this ranker and this question answering model. So what we need to do to train the ranker is the following. So we get the reference to the ranker. So this doc retrieval and ranker tf-idf wiki is the config file for the ranker. And this config file looks like this. It contains the data path for the text and data format. So in the original JSON format, in the original JSON file, it would say text format wiki, and the data path would be somewhere inside the DeepPavlov distribution. So what we need to do, we need to replace this destination with our path. So we say dataset reader data path assigned to text directory in our notebook. So we get the full text to this directory from within our notebooks. And data format we set to txt because our files are text files. And we also need to configure batch size of the training to 1000 to fit into memory, because this training is actually resource consuming thing. And I need to take the NC12 virtual machine to train this successfully. So the machine which contains 112 gigabytes of RAM, so that all models can fit into memory. And still I need to configure this batch size for everything to work. So then training is pretty simple. I say I want to train the model. And it takes some time, not too much, maybe a couple of hours. And then I can query this model. I can say I want to retrieve documents, for example, related to the term hydroxychloroquine, or I can provide the full question here. And it will give me the list of document IDs. So if I try now this model, so I train the model first, and then I need to build the combined model. I build the squad model for question answering. I build the squad model for question answering from original config, and I say download equals true because I need to fetch this model from disk. And then for ODQA, I say download equals false because I want DeepPavlov to use the model that I have just trained, which is residing on disk. So I built this combined model on top of my recently trained ranker, and I can ask it the questions like, what is coronavirus? And it will give me something like, a coronavirus is an imperfect gold standard for identifying in-county influenza admissions. So definitely that is related to coronavirus, but that is not something I want. And also, like, is hydroxychloroquine suitable for treatment? It will give me some strange result. So I think this is because the question answering model is not good enough, and I want to replace this with a BERT-based question answering model. Luckily, there is a pre-trained BERT question answering model inside DeepPavlov. So what I need to do is to replace this in the original config file. So if I take original English ODQR in FairWiki config, this one, it will contain this piece of code. It would say squad model, and this squad model would initially point to multi-squad no us infer JSON. And I want to replace this model with the BERT model. So the only thing I need to do, I need to say in this config, I take this squad model field and I replace it with BERT infer JSON. So I inject this BERT infer JSON in place of squad no ans infer JSON. And that would use different question answering model. I also need to download initially this BERT inference model. So that's pretty easy. It doesn't require any training. It just gets a new pre-trained model and uses it in our case. And now my answers get much better. So for example, if I say what is coronavirus, it will tell me it's a respiratory tract infection. Is hydroxychloroquine suitable? It is well tolerated. What is incubation period? 3-5 days. What is reproductive number? 5.2, and so on. It says even that COVID is similar to thrombogenesis. So those results, they seem pretty okay, but that is definitely not how the large bodies of scientific papers should be studied. It gives me some interface to it, but that is just an example. And I think much more powerful would be using some natural language processing techniques to extract some more meaningful information from scientific papers. So given this example, hopefully uh, you would be able to build on top of it if you want to create some more natural language processing pipelines and solve more interesting problems. The main goal of this video was to show you that Azure ML is the good place where you can run any Jupyter Notebooks code, switch between different computes, and finally and trained those large language models relatively easily. So thank you for watching this short course on advanced Azure machine learning topics. The main idea that I wanted to take away from this is that Azure machine learning can be used in very different scenarios. Like if you just want to run Jupyter Notebook, you can use it, switch between GPU, non-GPU compute. If you want to run large-scale experiments like gun training, you can do that as well. You can optimize hyperparameters and run a lot of experiments in parallel. You can do distributed training, and you can optimize and deploy model at scale. Everything that I covered in the series of videos, it is available in the GitHub repository. So maybe except this last one on training question answering model, uh, you can try it out yourself and get really familiar with it. And hopefully, if you manage to overcome some initial learning curve related with Azure ML, you would be able to use it very successfully for all your machine learning tasks, including research tasks, and many things would be made simpler with Azure Machine Learning. So thank you so much. My name was Dmitry Soshnikov, and if you want to get in touch with me or provide any feedback to this course, you can get my contact information on my website. Thank you so much.